we're going to be doing some terrific trig and finding the sine, cosine, and tangent of acute angles. So our warm-up is just converting fractions into decimals. So 2/3, because we are rounding to the nearest hundredth. 2/3 is 0.666666. It just keeps going on forever. But since we need the nearest hundredth, you'll look at that 6, look at what's next to it. That tells us to round up, so it'd be 0.67. 7/24, when you do 7 divided by 24, you get 0.291. So then 0.291 would just be 0.29. To solve the equations for number 3, because that x is in the denominator right here, we can't have that happening. So we're actually going to multiply everything by x. So then it'll cancel out on the right. So then we'll have 0.8x equals 5.8. And then to finish solving that, we'll just divide by 0.8, and that will give us 7.25. And then last but not least, for number 4, to get that 8.5 out of the denominator, we're going to multiply both sides by 8.5. So then 8.5 times 0.94 is 7.99. And then that's it. That is our answer. So being able to solve equations like this is really important, because when we get into trig, you're going to sometimes have variables in the denominator, sometimes in the numerator, and you're going to have to kind of rearrange your pieces. So by the AA similarity postulate, a right triangle with a given acute angle is similar to every other right triangle with the same acute angle measure. So if you look at these triangles that we have down in here, we have our right angle that they all have in common. And then we also have this 32 degrees that in common. So if you remember with AA, you just need 2 angles that are the same, and we have our 2 angles. So with that, we know that the ratio between BC and AC is going to be the same as EF to DF, and the same as YZ to ZX. And the third side is also similar, but when you write the ratios, you don't have to include it. But these are trigonometric ratios. So, oopsie, wrong button. So, a trigonometric ratio, and let me change this blue. Or trig ratio is a ratio of 2 sides of a right triangle. And these ratios are going to change based on which angle you are looking at. So there are 3 sides labels, so to speak, that we will have. We'll have hypotenuse, opposite, and adjacent. So if we look at these triangles that we're given, let's start with this one on the left. Let's say we were talking about this angle that I just drew in, that purple angle. We'll just call it angle A. If I'm looking at angle A, first off, to label these sides, I would want to label my hypotenuse first. Remember that hypotenuse is always opposite of that 90-degree angle. And this is really important with trig, because when we set up these ratios, you're going to have to be able to identify hypotenuse, opposite, and adjacent. So then my opposite side will be the side opposite of the angle I'm looking at. So in this case, it'd be this far left side. And then adjacent, which also means like next to, adjacent will be one of the pieces of your angle. So this angle right now is made up of those 2 sides that I just highlighted. So my adjacent side is obviously not going to be my hypotenuse, but it will be the other side that makes up the angle. Okay. So if we look at the triangle in the middle, we'll do the same thing just to practice it. So let's say that we were talking about this angle instead now, and I'll just call this one, actually we'll call this one B. So let's say we were looking at this angle B. Again, my hypotenuse can always be labeled before anything else. It's always opposite of that 90, so it's going to be over here on the bottom side of the triangle. And then to find my opposite, we're going to go opposite of the angle all the way over that would be my opposite side. And then adjacent, again, is going to be one of the sides that makes up the angle that's not the hypotenuse. Okay? And then last but not least, let's look at this last triangle. And we'll look at this angle here. We'll do angle C. So notice all these triangles look pretty similar, but every time that we pick an angle that we're using, it always changes which side is the opposite. The only one that is always set in stone is your hypotenuse, because it's always opposite of that 90-degree angle. So now if I'm looking at this angle C, my opposite would be all the way across over here, and my adjacent would be down here, the last remaining side. Okay, so if you have that down pretty well, then you're probably going to have no problem at all with trig, because that's basically trig. So going to the actual trig, our first one is that the sine of an angle is the ratio of the length of the leg opposite, let me get my highlighter, opposite of the angle to the length of the hypotenuse. So some of you may have heard of SOHCAHTOA. This is what SOHCAHTOA looks like when you actually write out the whole thing. Sine is actually the first one, SOH, because sine of an angle is the opposite over the hypotenuse. So if you notice with the letters, we have the S, the O, and the H. So that's our SO. So if we look at the example we are given, if we look at angle A, the opposite side is this A over my hypotenuse of C. Now this is where trig gets kind of interesting, because if, let's say, I want to do the sine of B, and I'll use the light blue for this one, for the sine of B, you're going to have B over C. So you notice how changing which angle you're looking at changes how your ratio is set up. Our next trig ratio is cosine, and cosine is the ratio of the length of the leg adjacent to the angle to the length of the hypotenuse. So really similar to sine, except this in SOHCAHTOA is, CAH, is the ca, and that is the cosine of an angle is the adjacent over the hypotenuse. So again, if you notice the letters C, A, H, that's how we get that ca for SOHCAHTOA. So again, looking at the triangle, let's say I was doing the cosine of A. Cosine of A, I'm going to have my adjacent leg B over my hypotenuse. And if I was doing angle B, I would do my adjacent leg A over my hypotenuse. So sine and cosine are really similar, and they may actually be the exact same answer depending on which angle you are looking at. Our last trig ratio is tangent, and tangent is the ratio of the length of the leg opposite the angle to the length of the leg adjacent to the angle. So that is our TOA of SOHCAHTOA. It is the tangent of an angle is opposite over adjacent. And again, you notice the letters. We have the T, O, A, TOA. Okay, so just like sine and cosine, it all changes depending on the angle that you look at. So if we look at tangent of A, my opposite is A over B. But if I look at angle B, it would be opposite angle B over my adjacent of A. So you do have to make sure that you're careful about which side is which. Some people may find that it's easier to label the triangle before they do any of the trig ratios, but it's kind of up to you. So jumping right in, SOHCAHTOA, your new best friend. Do not forget it. Do not mess it up. If you get SOHCAHTOA down and you have all the letters, then you're going to be solid for this. So looking at this, we need to write a trig ratio as a fraction and as a decimal rounded to the nearest hundredth. So looking, we want cosine A. So that tells me I'm looking at A. Cosine is the K, C-A-H. So I already have my C. I need my adjacent and my hypotenuse. So looking at this, I know that 25 is my hypotenuse. And then because I'm looking at angle A, I know that my adjacent side has to be one of my highlighted sides, which would be 24, because remember, your hypotenuse can't be your adjacent. So we'd have 24 over 25, which is 0.96. Okay. Our next one, since I'm doing tangent of B, tangent is my TOA, my T-O-A. So I'm going to have to get rid of what I wrote before. I can leave the hypotenuse because, again, that doesn't change, but we are going to look at a different angle now. So tangent is opposite over adjacent. So looking at this, my opposite is 24 and my adjacent is 7. So we have 24 over 7. And 24 divided by 7 is 24 divided by 7. I did 27 on accident. 24 divided by 7 is 3.428, which would just become 3.423. And then last but not least, our sine of B. Sine is the SO in SOHCAHTOA, and sine is opposite over hypotenuse. We are still looking at angle B, so it makes your life a little bit easier. Our opposite is over here at 24. So we have 24 over our hypotenuse of 25, which gives us 0.96 again. It's totally fine for them to be the same. If you notice with cosine and sine, we did cosine of A and sine of B. So because we switched the angle that we were looking at, it made our answers the same. So if you have to use your calculator to calculate your trig ratios, let's say you want the sine of 72 or the sine of 51 or whatever the case may be, you have to make sure, this is super important, your calculator is in degree mode. If it's not, then it's really going to mess you up because radian mode does something completely different. So on your calculator that you use, just real quick, do sine of 52. And then you should get this 7.88017536. If you don't, depending on the calculator you have, if you have a graphing calculator, you're going to want to hit the button mode, which is generally next to your second button, and then go down to your third option, and you'll see radian and degree. If radian is blacked, then just push it over to degree and push enter. If you're using a scientific calculator, then you might have an actual like degree radian button. You might actually have to push like second in a button. If you're not sure, either look it up on Google or come bring it to me and I'll show you how to change it. So when you do this, and this is just going to be a practice to make sure your calculator is in degree, if you do the cosine of 23 and we're doing nearest hundredth, you should get 0.9205, which if I'm rounding to the nearest hundredth would just be 0.92. Tangent of 68, when you put it into your calculator, you should get 2.475086, keeps going on and on and on. So then when you round, you'd get 2.48. And then for sine of 57, when you put it in, you should get 0.83867, and it keeps going. So then that would just become 0.84. Okay, so just double check, make sure your calculator is in degree. If you're not getting these numbers, then it's not in degree, and just bring it to me and I'll show you. All right, so using trig ratios to actually find lengths. This is actually getting into real trig. So we want to find the length of BC. And so if you look at this, it is this side right here. And we are trying to round to the nearest hundredth. So first you have to decide, well, which trig ratio do you need? So it'll probably help you if you write SOHCAHTOA on your paper, whenever you do it. So knowing this, I know I'm going to have to use this 15 degrees. So I'm just going to label the triangle. I know my hypotenuse is that one. The 10.2 is opposite of the 15. and the highlighted side is the adjacent side. So then, because I'm trying to find the highlighted side, I know I need adjacent. So looking at SOHCAHTOA, I know I can't use sine because I don't have an adjacent. I don't have any A's. But I do have my opposite, and I do need the adjacent. So the one that has opposite and adjacent is tangent. So when you set this up, you'll have tangent of 15 equals opposite, which is 10.2, over adjacent, which we don't know, so we'll just call it x. So to solve this, you will have to first multiply both sides by x so that you can get it out of the denominator. So you have x times the tangent of 15 equals 10.2. And if you want, you can put a little multiplication symbol in there. So then to go from here, we'll divide by tangent of 15 on both sides. Now, if your calculator allows you, which most of them should, do not round until the very end. You can actually type 10.2 divided by tangent of 15 and just type it straight in and push enter, and it will tell you the answer. You don't have to like find what the tangent of 15 is and then like do something crazy. It's literally just type it in as you see it. And if you're not sure if your calculator does it, again, you can just bring it to me. But when we get that x is 38.066. So to round to the nearest hundredth, we'd need 38.07. And that would be in feet. Okay, so again, just to run through it real quick, we know we're using tangent because we need the adjacent side and the opposite side. Because we're looking at this angle 15 degrees. So when you set it up, you put tangent of whatever your angle measure is equal to your opposite 10.2 over x. And then you multiply both sides by x, divide by tangent of 15, and you get that x is 38.07 feet. Okay, so going to the next one, we want to find the length of QR. QR, there we go. And we are going to round, oh my goodness, what the world? Thing has a mind of its own. But we are going to round to the nearest hundredth again. So we are given this 63 degrees. So again, it's really easy if you just go through and label. My hypotenuse is actually this 12.9 because it's opposite of the 90 degrees. If I'm looking at 63 degrees, my opposite side would be over here, the QR, and my adjacent would be right next to it. So looking at this, I am going to want to have, or I'm going to need to have my opposite in my ratio and my hypotenuse because those are the only measurements I have. So because I have opposite and hypotenuse, SOHCAHTOA, you can whisper it to yourself 1,000 times, SOHCAHTOA, SOHCAHTOA. But the only one that has the OH is sine. So you have sine of 63 equals opposite. We don't know what it is, so we'll just put an x over hypotenuse, which is 12.9. So then to solve this, we're going to multiply both sides by 12.9 so that it cancels. So we have 12.9 times sine of 63 equals x. Again, your calculator should be able to just do this. And I want to see, I'm using a graphing calculator right now, a TI-83. If you have an 84 or a slightly newer one, it should still work the same. But you can actually just type 12.9 sine 63. You don't even have to put the multiplication in there because it'll give you the same answer regardless. But you should end up with 11.493, which would just become 11.49, and then it's in centimeters. Okay. Our next one, we're going to find the length of FD right here. So if you just take a second looking at the angle we have, 39 degrees, I know that my FD is my hypotenuse, the part I just highlighted. Opposite would be DE, and adjacent would be FE. So looking at SOHCAHTOA, if I am trying to find, oopsie, there we go. If I am trying to get SOHCAHTOA, I need my hypotenuse and I need my adjacent because those are the unknown and a measurement I actually know. So the only thing with adjacent and hypotenuse is cosine. So we'll have cosine of 39 equals adjacent, which is 20, sorry, over hypotenuse. We don't know, so we'll just put x. So then we'll multiply both sides by x to cancel it out. So we have x times cosine of 39 equals 20. And then we'll divide by cosine of 39. So then 20 divided by cosine of 39 will give you 25.735. So remember, if you're rounding to the hundreds, you take this number, you look at what's next to it. The 5 tells us to round up, so we know x is 25.74, and this is in meters. Oops, pushing random buttons. Okay. Our next one, we're going to find the length of DF. So looking at this, we have DF right here. And we are looking at this 51 degrees. So DF is actually my hypotenuse because it's opposite of the 90-degree angle. And then if I'm looking at this 51 degrees, the opposite side would be 17, and the adjacent side would be DE, which we don't know. So using SOHCAHTOA, again, I would highly recommend you just write SOHCAHTOA every time, or you write it at the top or something, so it's really easy to look at. But our unknown is our hypotenuse, so we know we have to include it. And then the only other measurement we have is the opposite. And the only thing that has opposite and hypotenuse is sine. So we are going to use the sine of 51 degrees is equal to opposite is 17 over hypotenuse. We don't know, so we just put x. To finish solving this, let's do purple. We will multiply both sides by x just like we've been doing. So then you have x times sine of 51 equals 17. And then we'll have to divide by the sine of 51. So then x equals 17 divided by sine of 51. Oopsie, not 55. 51 is 21.874. 9, and the only reason I went out to 4 is to show you if you ever have a case where the number next to the one you needs isn't a 5, but then if you went to the next space it would be. Remember, we're still rounding to the hundredths place. So because we're rounding to the hundredths place, I don't really care what's after that besides the number right next to it. So this would be 21.87 meters. Just like that. Okay. All right, our next one, we want to find the length of ST. Draw. There we go. So we are looking at this angle 42. Remember, as you're watching this video, you can pause it and try and do it before I do it. But since I'm looking at this 42, this 9.5 is going to be my hypotenuse because it's opposite of the 90. So then if I'm looking at the 42, SU would be my opposite, and ST would be my adjacent because it helps make up the angle itself. So then, SOHCAHTOA, it's coming. So looking at this, I have a hypotenuse measurement, and I need my adjacent measurement. So the only thing that has adjacent and hypotenuse in its ratio is cosine. So we are going to use cosine of 42 equals adjacent, which we don't know. So x over hypotenuse is 9.5. So then to solve this, we're going to multiply both sides by 9.5. So we have 9.5 times cosine of 42 equals x. So the 9.5 cosine of 42, when you put it in the calculator, you should get that x equals 7.059, which would round up to 7.06, and this is inches. Okay. All right, for number 8, we actually want to find ED and EF. So ED, we get to draw, and EF. So sometimes you may actually have to set up multiple trig ratios to find the things that they want. So since they ask for us to find ED and EF, we definitely want to label these. So my ED is opposite of my 90, so I know it's my hypotenuse. My EF is opposite of 72, so it is my opposite side. And then 31 is my adjacent side. So because we have two unknowns, you're actually going to have to use two different trig ratios. So for the first one, get yellow. Let's say we want to find ED first. With ED, I have hypotenuse that I need, and then I also have this adjacent measurement that I know. So because I have hypotenuse and adjacent, that means I'm going to want cosine. So we'll do cosine of 72 equals adjacent 31 over hypotenuse, which we don't know. So then to finish this, you would multiply both sides by x. And you get x times cosine 72 equals 31. And then you divide by cosine of 72. So you get x equals 31 divided by cosine of 72. Oopsie. 31 divided by cosine of 72 is 100.318, so 100.32. And actually this is ED, so I'm just going to replace that with ED. And that is in yards. Man, I'm a slacker. Yards. There we go. Okay. So then if I am looking at EF, with EF, I need my opposite and my adjacent again because I don't know what it is. So opposite and adjacent is tangent. So we would have tangent of 72 equals opposite, which we don't know, so I'll just put x over adjacent, which is 31. So then you'll multiply both sides by 31. So you have 31 tangent of 72 equals x, and then 31 times the tangent of 72 is 95.408 or 95.41. And this is EF, so I'll label it EF. Okay, so notice even with the same angle, I can find any of the sides that I need to for this right triangle. Remember, by the way, that trig ratios only work for right triangles and they only work for the acute angles in the right triangle. So just keep that in mind as you're doing stuff. Our last one is about the Palatzbahn or something like that in Switzerland. It is the world's steepest cog railway. Its steepest section makes an angle of about 25.6 degrees with the horizontal, and it rises about 0.9 kilometers. To the nearest hundredth of a kilometer, how long is this section of the railway? Some of you, by the way, may find it easier if you highlight or like mark up the actual question. That way you can kind of see what your answer should be about. So our first one is to make a sketch. So we know we have right triangles, but if you think about it, if this is a cog railway, here's our little train. And we'll do a little smokestack or something. Boop. Okay, so this little train has to go up the hill. So to label this, our first little hint is that it's 25.6 degrees with the horizontal. Well, with the horizontal means that if you take that angle you have and you go along a horizontal line, then it's going to be the angle formed between those two things. Let me see if I can get there. So I know that this angle is 25.6 degrees. And then my other hint is that it rises 0.9 kilometers. So if we're rising, that's going to be this over here. And the answer is AC. because if you were to label this ABC, AC would be your diagonal, which makes sense because your little train is going to go up the hill. So now we have it set up and drawn. We can actually do it. So looking at this, again, we're still doing SOHCAHTOA. Oops. So looking at these sides, we're looking at that 25.6, do blue. This 0.9 is opposite of that, and then where the train is the hypotenuse. And then AB, that bottom piece, would be the adjacent. So because I need my opposite side and my hypotenuse, opposite and hypotenuse is sine. So then we have sine of 25.6 equals opposite of 0.9 over hypotenuse, which we don't know. So then to solve this, you multiply both sides by x. So then we have x times sine of 25.6 equals 0.9. And then to finish it off, you would divide by sine of 25.6. So then x equals 0.9 divided by sine of 25.6 equals 2.082. So we'll just do 2.08, and this is kilometers. And that is the final answer. So just think, in just under a kilometer, it rises just over 2 kilometers. So if you have a word problem, just draw yourself a picture and label it. Your homework is on page 545 in the textbook. And just be careful. I believe it's number 71. With number 71, you're going to actually estimate the tangent value. Okay, to help you solve the equation. So if you have any questions, leave it in the comments below, or just ask me in person. Totally up to you. But I hope this video helped. Thanks for watching.